All right, lesson 16.2. We're going to start discussing graphing inequalities in two variables. We're going to graph on a coordinate plane the solutions of a linear inequality, and then we are going to interpret the graph of the solutions of a linear inequality. So the solutions of a linear inequality in two variables can be represented in the coordinate plane. So we discussed yesterday about how points that lie in the shaded region are solutions. And today, at the end of that video, I mentioned that they could also lie on a solid line. So today, we are going to discuss those solid lines versus dotted dashed lines. Okay, so a boundary line. A boundary line is a line that separates a coordinate plane into two regions, and those two regions are what we refer to as half planes. Okay, so example A, we're going to graph the linear inequality y is less than or equal to 2x plus 3. So we first need to graph the corresponding linear equation 2x plus 3. And if we graph 2x plus 3, that tells us that our y-intercept is 3 and our slope is 2. So if we go on this graph and we put a point at 3, and then our slope is 2, so that's up to right 1 point, up to right 1 point, up to right 1 point, and then we connected those points all the way down. That is how they got that graph. Okay, so you've already graphed equations, but today we're going to start graphing inequalities. So what does that mean? Well, you can use a test point in one of the half planes to see if the solution of the inequality using 0, 0, or 0 is less than 2x, where x is 0 plus 3 is a true statement. The origin is the quickest and easiest point to use as your test point because both x and y is 0. Okay, so if you substitute in 0 for x into our inequality, you'll get 0 is less than or equal to 2 times 0 plus 3. And if you simplify that, you get 0 is less than or equal to 2 times 0 is 0, and 0 plus 3 is 3. Well, 0 is less than or equal to 3. That's a true statement. So because that's a true statement, that means that the point 0, 0 in the half plane is a solution. So you're going to shade the plane, the half plane, where that test point is. You're going to shade this whole region here. Now, another way that you can remember this is if you look at the inequality and you just simply read y is less than or equal to, if you read y is less than or equal to, from this point where the graph touches, let me change my color here. If you look at this point, which is your y-intercept, where from this point on this line that I have graphed, where from this point are my values where y is less than? Well, they're down here. This is where all my y values are less than 3. So I'm going to shade that region where y is less than 3. So you can do it either two ways. You can pick a test point, which if you can use 0, 0, use 0, 0. If it's a true statement, shade that region that the origin it is. If it's a false statement, shade the opposite region. Or just simply know that if you get y is less than, shade the region where your y values are less than. If you get y is greater than, shade the region where the y values are greater than. Step 2, let me just read that point. Test a point in one of the half planes to see if the solution is of the inequality. And if you substitute in and you get the true statement, then it is a solution. If the point you tested is a solution, shade the half plane in which it lies, which we did. Our test point was here, and we shaded that region. I'm going to change back to red so you can see my annotations here clearly. If not, if the test point that you chose is not, shade the other half of the plane. So if that test point gave you a false statement, you would have shaded up above. Okay. In example A, the solution set includes the points on the boundary line. The solution set is a closed half plane. In an inequality containing less than or greater than, the solution set does not include the points on the boundary line, so the boundary line is dashed, and the solution is an open half plane. So this math term over here is a summary of that paragraph there. Closed half plane includes the point on the boundary line, and it's a solid boundary line. Closed is a solid boundary line. Open does not include the points on the boundary line, and it is a dashed or dotted. Dash or dotted. Okay, and a closed is going to be less than equal or greater than equal. So you should know that less than equal or greater than equal is solid. A dashed is going to be less than or greater than only, which is dashed or dotted. So in our example A, it was a solid line because if you look at our inequality symbol, it was less than or equal to. You have a solid line underneath, less than solid 9 underneath, so it's a solid line. Greater than solid, you have a solid line underneath, so your graph is going to be a solid line. Okay, that's an easy, quick little tip that you can use when graphing to determine if it's a solid line or not. Okay, now you can also use Desmos. You can use Desmos because if you go in Desmos, I'm going to graph example A for you and you can look and compare. Example A was Y, and if I pull up my keyboard here, Y is less than or equal to 2x plus 3. Now look at there. If you compare this to the graph that you see in example A, it's exactly what you see in example A. A solid line crossing over at 3, -1.5 for x value, with all my points shaded below it. If you look at example A. Oops, I went too high. Example A. Look, solid line at 3 and -1/2 and shaded below. Okay, so you can use Desmos to graph inequalities, but I also want you to learn by hand. So let's look at part B. Let's look at example B and see if we can do this by hand. Now, this is a standard form, which means that we're going to have to solve the equality for Y. Solve the inequality for Y so that we can have our inequality in slope-intercept form so that we can pull out our slope and our y-intercept. In order to do that, I'm going to write all the steps out here to the right, the way that you're used to seeing me write them. X plus 2y is greater than 8. We're trying to isolate y, so we first need to subtract x from both sides. When I subtract x from both sides, I'm left with 2y is greater than -x plus 8. Then I need to divide by 2. I'm dividing by a positive number, so my inequality symbol is going to remain greater than, y is greater than, -1/2 x, because this is understood 1. And I'm going to write my slope as a fraction 1/2 plus 4, because 8 divided by 2 is 4. Now I can pull out my y-intercept and my slope. My y-intercept is 4, so I'm going to put a point at 4. My y-intercept, B, is positive 4. So I'm going to put a point at positive 4. My slope is -1/2. So from this point, I'm going to go down 1, right 2, point. Down 1, right 2, point. Down 1, right 2, point. And then I'm going to connect those points with a dotted dashed line because why? My inequality symbol is greater than. There's no solid line underneath. It's only greater than. So I'm going to connect those points with a dotted or dashed line. Make sure when you're connecting your points that you are clear with your line. Your boundary line has to be a clear dotted or dashed because it does matter. They mean two different things, okay? Open plane versus closed plane. Remember, a solid line with a closed plane means that solutions lie on that solid line. A dotted dash means that solutions do not lie on that boundary line. So from this point, if we look at just our inequality symbol, greater than, y is greater than. So from this y-intercept point, in what direction do I need to shade? Up or down? If y is greater, where are my y values greater? Well, they're up here. So I'm going to shade all the region that's above. Now, step 3 shows where you use the test point. That's if you don't remember that you shade above for greater or below for less than, you can use the test point. Again, they use the origin as a test point because it's clearly in one side of the half plane. And when they substituted in, they got 0 is greater than -1/2 times 0 plus 4. And 0 is not greater than 4. So because that point is not, they're going to shade in the opposite plane. Okay, now you can also, again, go to Desmos, type in x plus 2y is greater than 8. X plus 2y is greater than 8, and copy over your answer. Intersects at 0, 4 with a dotted dashed line that you see here, shaded up. Shaded up. Okay, and you would just pick some other points. Typically, people would pick the y-intercept and the x-intercept and connect those 2 points, dash it, and then shade above. Okay, so that's example B. So I want you to pause the video and I want you to try these A, B, C, and D. You should be graphing 4 different graphs, A, B, C, and D. And you can graph them on the side of your paper on 243, and you may have to use the back page 244 on the side margins, or if you have graph paper, you can use the graph paper as well. So you can do it by hand, or you can use Desmos. So pause the video and attempt A, B, C, and D. Okay, I'm going to briefly hover over A, B, C, and D so that you can check your work. Okay, here's the graph for A. If you need to pause and check your work, you can. Here's the graph for B. If you need to pause and check your work, you can. The graph for C. The graph for D. And if you have any questions about those 4 graphs, you can ask tomorrow in the Google Meet, or the next day that we have a Google Meet. You can ask questions about those 4 graphs. So when graphing a linear inequality, is it possible for a test point located on the boundary line to determine which half plane should be shaded? Absolutely not. You cannot use a test point on a boundary line to determine if one side of the half plane is shaded or not. Now, you can use the boundary line to determine if the boundary line is solid or dotted. And if you get a true statement, then it would be solid. And if you get a false statement, it would be dotted. But as far as the shading goes, you cannot use a point on the boundary line. This will determine only if the line itself is part of the solution set, which it is for less than, equal, or greater than equal. To determine which half plane to shade, the test point must be above or below the boundary line and clearly in one of the shaded region areas, in one of the half plane regions. Okay, question 2. Axel tried to graph the inequality 2x plus 4y is less than 8. He first graphed the linear equation 2x plus 4y equals 8. He then chose the test point 2, 1 and used his result to shade above the line. Explain Axel's mistake and how he should correct it. Well, Axel's test point 2, 1 lies on the boundary line. If you graph that point, let's go to Desmos. 2x plus 4y is less than 8. Two x plus 4y is less than 8. Here is our graph. Here's our graph. And he chose the point 2, 1, which is this point right here that I'm hovering my mouse over. That point lies on the dotted line. Okay, that point lies on the dotted line. So because that point lies on the dotted line, it's not going to tell you what area, what boundary half plane to shade. It would only tell you if it's dotted or solid. Okay, so Axel must choose a test point that is not on the boundary line to determine the half plane to shade. Axel could use the origin, of course, 0, 0. Then the inequality would give 2, 0 plus 4, 0 is less than 8, which is true because 0 is less than 8. Okay, so since the origin lies below the graph of 2x plus 4y equals 8, Axel should shade below the dotted line. And if you use Desmos, you'll see that Desmos graphs below the dotted line. Number 3, Axel and Anisa try a new plan in which they can upload no more than 350 terabytes per month. On the grid below, the x-axis represents the number of terabytes. that Axel can upload. And the y-axis represents the number of terabytes that Anisa can upload. So suppose that Anisa does not upload anything for a month. Write an inequality that represents the amount of data that Axel can upload. Well, if Anisa uploads nothing, then Axel can upload 250 gigabytes. And Axel, remember, the X values represent Axel. So X is Axel. It gives you that information. Y is Anisa. So that means that the X values have to be less than or equal to 350. The amount of data that Axel can download has to be less than or equal to 350 terabytes. So you would draw a vertical line, a vertical solid line, because he can upload exactly 350 at 350 and shade to the left where the values are less than. So if Axel does not upload everything, so if X is 0, then what about Anisa? Well, Anisa, which is Y, can upload less than or equal to 350. So that's going to be a horizontal solid line at 350 because she can upload exactly 350 and any amount less than 350. The graph below represents another plan that Axel and Anisa considered. The x-axis represents the number of terabytes of data from photos that can be uploaded. So the x is the photos and the y is the text. The y represents the text. So now they're saying, okay, how much can I use for pictures and how much can I use for text? Identify the x-intercept and the y-intercept. And what do they represent? Well, the x-intercept, where does this line touch across the x-axis? Right here at 180. And where does this line touch across the y-axis? Right here at 360. So what do those values mean? What that means that Axel and Anisa can upload up to 180 pictures as long as they download 0 text or receive 0 text. And they can receive up to 360 text as long as they receive 0 pictures. So the x-intercept represents the maximum number of terabytes of photos that can be uploaded during a month in which no text files are uploaded. The y-intercept, 0360, represents the maximum number of terabytes of text files that can be uploaded during a month in which no photos are uploaded. Determine the equation for the boundary line of the graph and justify your response. So now you're going from a graph to an equation. And at this point, you can use Desmos to check your answer, but you cannot use Desmos to write an equation of an inequality from a graph, but you can use it to check. So you're going to have to write y with some inequality symbol, pull out your slope and your y-intercept. So y, what inequality do I need to use? First of all, here's my y-intercept. Where is my shaded region? My shaded region is below that point. So y is going to be less than. Now, is it less than or is it less than equal? My boundary line is solid, which means I'm going to have a solid line underneath. So it is going to be equal to. Y is less than or equal to. Okay? Y is less than or equal to. And what is your slope? What is your slope of this graph? Okay, so you're going to have to pick 2 pretty points. And 2 pretty points is already given to me that will make my life easier are the x and y intercepts. Okay, x and y intercepts. So y2 minus y1 over x2 minus x1, where you have a point at 0, 360. And you have a point at 180, 0. So x1, y1, x2, y2. So your points, your slope is going to be 0 minus 360. That's 0 minus 360 all over 180 minus 0. Okay, so negative 360 divided by positive 180, negative 360 divided by positive 180 is negative 2. So my slope is negative 2. So y is less than or equal to negative 2x. And what is my y-intercept? 360. That is the inequality of this graph. Now, you can check it by going to Desmos and verifying that that is the same graph. So y, let's clear this out. Y is less than or equal to negative 2x plus 360. So I'm going to have to zoom out a great amount because of my graph here. So let's zoom out. I have a solid line that's intersecting at 360 and down here at about, looks to be about 180, solid line shaded to the left. Well, here's a graph, 360, 180, solid line shaded to the left. So my inequality is correct. Okay. So I just went through all the steps for B and C. I just realized that B asks you to write an equation of the boundary line only. And then part C said write a linear inequality to represent the situation. Okay. All right, check your understanding 5, 6, 7, 8 is your homework. Lesson 16 to practice 9, 10, 11, 12, 13 is your homework. And do not forget about the activity practice that's on page 247 and 248 that is numbers 4 through 12 that also covers 16 too.